So we have the trigonometric function 1 minus tangent of x divided by x minus pi over 4. So we have to determine the limiting value of this given function when x approaches pi over 4. So we clearly see that when we substitute for the value of x, we have 1 minus tangent of pi over 4, which is equals to 1, divided by pi over 4 minus pi over 4, which is 0. So that means we are getting a 0 over 0, which is an indeterminate form. So that means we'll need to simplify our given function. And what we're going to do, we're going to change the limit from x to h. So we have limit h approaching 0, 1 minus tangent of, now that means we'll also need to change x. So x will now become pi over 4 plus h divided by pi over 4 plus h minus pi over 4. So the pi over 4 and pi over 4 gets cancelled. Also, we have tangent of a plus b is equals to tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b. So we're going to expand tangent of pi over 4 plus h using this identity. So we're going to get limit h approaches 0. We have 1 minus tangent of pi over 4 plus tangent of h divided by 1 minus tangent of pi over 4 times tangent of h whole divided by h. Now we know the tangent of pi over 4 is 1, so we have limit h approaching 0. So we have 1 minus 1 plus 10h in the numerator divided by 1 minus tangent of h whole divided by h. So we have 1 over h. So now we have limit h approaching 0, 1 over h multiplied to, so we're going to combine 1 and the second term. So we have 1 minus tan h, so this is going to be the common denominator. We cross multiply 1 with 1 minus tan of h, and that will become the numerator, the first term of the numerator, minus of, we have 1 plus tan h, 1 plus tangent of h. So that is going to give us limit h approaching 0, 1 over h times 1 minus tangent of h minus 1 minus tangent of h over 1 minus tangent of h. Now the 1 and 1 gets cancelled, so that is going to leave us with limit h approaching 0, 1 over h times the 1 and 1 gets cancelled, so we have negative 2 tangent of h divided by 1 minus tangent of h. So we can rewrite our limit as limit h tends to 0, negative 2 divided by 1 minus tangent of h times limit h approaching 0, tangent of h over h. Now the limiting value of tangent of h over h is going to be equals to 1, so that is the definition. So this entire limit is going to be equals to 1. So that leaves us with only one function. So when we substitute for the value of h, so that gives us negative 2 divided by 1 minus tangent of 0. The tangent of 0 is simply 0, so we have negative 2 divided by 1 minus 0. So our limiting value of this particular function is -2. So let us move on to the next question. So we have to determine the limiting value of the given trigonometric function when x approaches pi over 2. Clearly, when we do a direct substitution for the value of x, we are going to get an indeterminate form of 0 over 0, meaning we'll need to change the function, or we're going to need to change the simplify the given function by changing the limits. So here we do a limit change. So we have limit h approaching 0. So that would mean we will be replacing x by pi over 2 plus h whole divided by pi over 2 minus of pi over 2 plus h, and we have whole squared. So that becomes one limit h tending to 0. So we have sine pi over 2 plus h, so that will be sine pi over 2 plus theta is equals to cosine of theta, and pi over 2 plus theta means it's in the second quadrant. So in the second quadrant the sine function is positive, so the resultant will be positive cosine theta. So we have 1 minus cosine of h whole divided by, so the pi over 2 and pi over 2 gets cancelled, so we have negative h squared. So now we're going to further simplify 1 minus cosine of h. So we're going to do the substitution, 2 times sine squared h over 2. So we have limit h tends to 0, so 1 minus cosine of h will become 2 times sine squared h over 2 divided by h squared. So what we're going to do, we're going to divide the denominator, that is h squared, by 4, and we are going to multiply by 4. So that means we have 2 over 4. So we have 2 over 4 times limit h tending to 0, we have sine of h over 2 divided by h over 2, and this is repeating twice, so we have whole square. So that gives us half, and the limiting value of this particular function sine h over 2 divided by h over 2 is simply 1 as per the definition of limits. So the limiting value of a given function is equals to half. Let us do another problem. So here we have another trigonometric function. We need to determine its limiting value when x approaches pi over 2. So we begin by changing the limit. So we have limit h going to 0. So that means we have to substitute x by pi over 2 plus h. So we have sine x will get replaced by pi over 2 plus h minus 2 times cosine of pi over 2 plus h whole divided by pi over 2 minus of pi over 2 plus h plus cot pi over 2 plus h. So we have limit h approaching 0. So we have pi over 2 and minus pi over 2, so it gets cancelled, leaving us with negative h. Now sine of pi over 2 plus h is going to be equals to cosine of h. Now pi over 2 plus h means it's in the second quadrant. So in the second quadrant we have sine is positive. So this value of sine is going to be positive. Minus 2 times, so cosine of pi over 2 plus h will become sine of h. However, we know that the sine function is positive in the second quadrant. Pi over 2 plus h, it means the second quadrant. So since we're working with a cosine function, the result will be the negative times of whatever we got. So which is negative of sine h divided by, so pi over 2 minus pi over 2 gets cancelled. So we have negative h. Then we have cotangent of pi over 2 plus h. So that will become tan h. So similarly, this is in the second quadrant. So second quadrant, cotangent function is going to be negative. Now we have arranging all the terms. So this is going to give us limit h approaching 0. So negative 2 times negative sine h will be 2 times sine h minus h cosine of h divided by negative h minus tangent of h. Next, what we're going to do is we're going to multiply both numerator and the denominator by negative 1. So that will become limit h tends to 0. So negative h of cos h will become positive cosine of h times h minus 2 times sine of h divided by h plus tangent of h. Now we're going to divide both numerator and denominator by h. So we have limit h going to 0, h cos h over h is going to give us cosine of h minus 2 times sine of h divided by h whole divided by h over h is going to be 1 plus tangent of h divided by h. Now we're going to apply the limiting value of h going to 0 to each of the terms in both the numerator and the denominator. So we have cosine of 0 minus 2 times limiting value of sine h over h is going to be 1 divided by 1 plus the limiting value of tangent of h over h, which is going to be 1. So we have 1 minus 2 divided by 2. So we're getting the limiting value of negative half. So this is the limiting value of our function, of a given trigonometric function, when x approaches pi over 2. So this is the value. Let's move on to the next question. So we need to determine the limiting value of the given function when x approaches pi over 4. So we change the limit. So we have limit h tending to 0. So in the numerator we have cosine of pi over 4 plus h minus sine pi over 4 plus h whole divided by pi over 4 minus of pi over 4 plus h times cosine of pi over 4 plus h plus sine pi over 4 plus h. So now what we're going to do, we're going to compute each of the compute in the sense we are going to expand each of the trigonometric function one by one. So let's start with the first one. So we have cosine of pi over 4 plus h. So here when we expand it, this is going to give us cosine of a times cosine of b, which is h, minus sine of a times sine of b. So cosine of pi by 4 is 1 over root 2 times cosine of h minus 1 over square root of 2 times sine of h. Then we are going to expand the second term, which is sine pi over 4 plus h. So we have the identity sine of a plus b, which is equals to sine of a times cosine of b plus cosine of a times sine of b. So we have sine of a, so a here is pi over 4 times cosine of b plus cosine of a, which is pi over 4, times sine of b. Now we have sine pi by 4, which is 1 over root 2, times cosine of h plus 1 over root 2, times sine of h. So let's rename it as equation number 1, and the second one is equation number 2. Now first thing, we are going to do 1 minus 2. So that is going to give us cosine of pi over 4 plus h minus sine of pi over 4 plus h. So that will be equals to, so when we're doing subtracting 2 from 1, so we have negative 2 over root 2 sine of h. So the 1 over root 2 cosine of h gets cancelled, and next what we're going to do is we're going to add 1 and 2. So adding 1 and 2, so that means we have cosine of pi over 4 plus h plus sine of pi over 4 plus h. So that is going to yield 2 over square root of 2 times cosine of h. Now let us substitute this value into our function. So we're going to have limit h approaching 0. So in the numerator we had 1 minus 2, so that will be simply negative 2 over square root of 2 times sine h divided by, so we have pi over 4 minus a pi over 4 plus h. So here the pi over 4 and pi over 4 will get cancelled, leaving us with negative h. So we have negative h in the denominator multiplied to equation 1 and plus 2. So we have 2 over square root of 2 times cosine of h. So what we can do, we can cancel the negative sign. So the negative sign gets cancelled, and 2 over root 2 also gets cancelled. Now we can rearrange it. So we'll get limit h tending to 0. We have sine of h over h multiplied to the limit h tending to 0, 1 over cosine of h. So the limiting value of sine h over h is going to be 1, and limiting value of 1 over cosine of h will be 1 over cosine of 0, which is also 1. So we get the limiting value of 1. Let us do another problem. So we need to determine the limiting value of the given trigonometric function when x approaches pi over 3. So we change the limit. So we have limit h tending to 0 square root of 3 minus tangent of pi over 3 plus h divided by pi minus 3 times pi over 3 plus h, which will be equals to limit h tends to 0 square root of 3 minus tangent of pi over 3 plus h whole divided by pi minus 3 of h. So we have limit h approaching 0 square root of 3 minus tangent of pi over 3 plus h divided by negative 3h. Now what we're going to do, we're going to expand tangent of pi over 3 plus h in the numerator. So what we can do, we can use the identity that tangent of a plus b is equals to tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b. So let us use this. So we have tangent of pi over 3 plus h. So that will become tangent of pi over 3 plus tangent of h divided by 1 minus tangent of pi over 3 times tangent of h. Now tangent of pi over 3 is equals to square root of 3. So we have square root of 3 plus tangent of h divided by 1 minus tangent of pi over 3, which is square root of 3 times tangent of h. Now we're going to substitute this value into the numerator part. So let's further work on the numerator. So we have square root of 3. So let me get rid of all the values. So we have square root of 3 minus tangent of pi over 3 plus h. So that will become square root of 3 plus tangent of h divided by 1 minus square root of 3 times tangent of h. Now we combine it. So that is going to give us 1 minus square root of 3 times the tangent of h. So square root of 3 multiplied to 1 minus square root of 310 will be square root of 3 minus 3 times tangent of h minus square root of 3 minus tangent of h. So the square root of 3 and negative square root of 3 gets cancelled, leaving us with negative 4 tangent of h divided by 1 minus square root of 3 tangent of h. So this is the entire numerator. So let us substitute this into our given function. So now we have, this will be equals to limit h tends to 0. We have negative 4 tangent of h divided by 1 minus square root of 3 times tangent of h whole divided by negative 3h. So we can get rid of the negative sign by multiplying with negative 1 with to both the numerator and the denominator. So we have 4 over 3 times limit h tends to 0. We have tangent of h divided by h times limit h approaching 0, 1 over 1 minus square root of 3 times tangent of h. So we have 4 over 3. So the limiting value of tangent of h over h is going to be 1 multiplied to 1 over 1 minus square root of 3 times tangent of pi over 3. This is 0, tangent of 0, h is 0. So we have negative, so we simply have positive 4 over 3. So this is going to be the limiting value of a given function when x approaches pi over 3.